So there's nothing conceptual in this question. It's really just about applying the different formulas for the arithmetic progression. So if we start here, the first term is 3, second is 7, which means the common difference is 4. That means I can now write the nth term. Here it happens to be 3n. So that would be the first term, 3, plus the common difference times 3n minus 1. And the reason I need that is because I'm given the sum, and this would help me figure out the value of n, and specifically 3n. So sum would be the average of the first and last term, which is first term is 3, last term is right here. So I take the average of those two, and that would be the average for the entire set of numbers from 1 to 3n. And I multiply it by the number of terms, which is 3n. So that's the condition that will give me what n is. And I just have to simplify this. This is 6 plus 12n minus 4, so that becomes 12n plus 2. And dividing it by 2, so that becomes 6n plus 1. So this equation reduces to 6n plus 1 times 3n. Now note, this is also divisible by 3, so I'm going to divide both sides by 3. So I end up with this equation. Now, this will be a quadratic in general, and you can use the quadratic formula or factor it. But most of the time, these types of equations, where it's a positive integer, you can just kind of guess a value. And so you might be able to see that if n is 10, this is 10 times 60 plus 1, which is 61. So that's kind of how I did it. But if you don't see it, then your option is to solve it by writing the standard quadratic equation. Now, once you know what n is, and if I apply that to this condition, what we're saying is sum to the 10th term, what does this number needs to be so that the sum is then greater than 1830? So we know our first term is 3, and I can find the 10th term, which would be the first term plus the common difference times 9, because it's 10 minus 1, and that would be 39. So here, that sum would be the average of the first and last term, and then multiplied by the number of terms, which is 10. And so this is the inequality I'm interested in. That knocks out the 0. This is 42 over 2, which is 21. And next I'm going to divide by 3. So m needs to be greater than 61 over 7, which is 7 times 8 is 56, 5, 8, and 5/7. We're looking for the smallest positive integer that's greater than that number, and that will be 9. So the answer is choice B.